All right, hi everybody. So today we're going to look at another projectile off a cliff, slightly different than what was posted yesterday. So no quadratic formula today. We're just still going to kind of do that. The goal of today is going to be trying to find this launch velocity. So projectile is launched into the air off a cliff, 125 meters tall, at an angle of 30.2 above the horizontal. Projectile lands 455 meters away from the base of the cliff. What is the launch velocity of the projectile? Okay. So this one takes a slightly different approach to how to solve stuff out, because if you think about the kind of three things needed to do to solve any projectile, the first step is to find your v initial x and v initial in the y. So if I think about my little right triangle, our goal usually is to find these two things first and then go. Well, we can't do that right now. So let's go to the second step. Second step is to find time. Okay? So if we think about it, time is one of those things where if you find the time of the projectile, you can basically solve for anything else you need. Okay? So let's find time. Before I do that, though, let's do kind of our standard list out our givens. So x-axis, we have delta x is 455. Delta y, acceleration is negative 9.8 meters per second squared. And the delta y is negative 125 meters. Why am I saying negative 125? Because it is going to drop 125 meters. Sorry, that's going to cut off. Let me zoom out a little bit. Boom. Okay. So you can also send the x a 0 if you want. Okay. So let's find our time. And let's start in our x-axis. Y-axis, well, that has one equation. Okay. So delta x is equal to v initial x t. Okay. So delta x I know is 455. Now, my end goal is to find my launch velocity. Okay, so what I should probably think about doing eventually is how to incorporate my launch velocity into my equations. Now, usually in the past, you can solve for these things right away. So let's just think about that. Okay, so if I think about my launch velocity, incorporating it into this equation, part of my right triangle, I have this v initial x. Well, if we think about how we've gone about solving for v initial x, well, we've used the cosine function. So we have cosine of theta, v initial x over vi. So v initial x is equal to vi cosine of your theta. This is kind of the standard equation we've been using to solve for our v initial x. Okay? Well, why don't I just take this and plug it in for here? So I can say v initial cosine theta t. Okay? Which, yeah, that should work out. Now, once again, I just replaced it. We're good to go. Now, we do run into an issue. I have two unknowns. I don't know v initial. I don't know time, so I do have to pause there. Okay? Well, let's move to our y-axis. On our y-axis, once again, time is the thing we want to solve for. Well, based on my givens, acceleration and delta y, I probably should find an equation that has both these in there and time, which then is my delta y equals v initial y t plus 1/2 t squared. Okay. Once again, let's plug myself in. So negative 125 is equal to, hey, v initial and the y. Well, if I switched out the x for this function, I probably should do the same thing for my v initial y, switching out with the function as well. So that's my sine. So sine of theta y over I. Okay. So I can write this as v initial sine theta t minus 4.9 t squared. 4.9 is 1/2 of 9.8. Okay. So what all I've done is I've taken my two standard equations and I've simply substituted out v initial x and v initial y with their two functions we've usually used to solve for them outright when they were given a launch velocity. But this time, since we're trying to find launch velocity, we can't do that. Well, I have two equations and two unknowns. In each equation, the unknowns are the same. So now math tells me I can solve these out doing some substitution. So how I'm going to substitute this out is I'm going to get rid of time. And by means of getting rid of time, I'm going to set it so there's no more t's in the equation. So by solving this equation for t, I could plug this new quantity in for both t and t squared, and all the times are canceled out. So it's going to look something like this. I'm going to say negative 125 is equal to vi sine theta times 455 vi cosine theta minus 4.9 455 vi cosine theta squared. And yes, you could plug in your cosine value of 30.2. I'm just kind of not doing that right now to save me some space. And so now it looks terrible, but it's a solvable thing. Now, one thing we can do right away is I'm going to cancel out this VI and this VI because they're on uneven levels. So we do that. And so it gives me negative 125 is equal to 455 sine theta cosine theta minus 4.9 if you know the trig function sine over cosine, that's tangent. If you don't, that's totally fine. So now it's just kind of let's plug and chug this stuff out. So what I'm going to do first is I'm going to condense this down. So this is my first goal. So taking 455 times the quantity of sine of 30.2 divided by cosine of 30.2, I should get 264.82. So then I'm going to say 264.82 minus 4.9, 455 over VI cosine theta squared. Now, this cosine, this whole squared business, I'm going to wait till I absolutely positively need to deal with it. So this fraction, I'm just going to kind of ignore for a bit. So take this, move it over, and that gives me a negative 389.82 equals negative 4.9 times that fraction squared. Now I'm going to divide both sides by negative 4.9 because it's multiplied by this fraction. So that gives me, negatives are gone, so that gives me 79.55 is equal to this quantity. Now, some of you might want to do 455 divided by the cosine of your 30.2. It's totally fine. One thing you have to remember is this v initial stays in the denominator. For me, I'm just going to get rid of the squared right now. And so I'm going to square up both sides. And so by squaring both sides, that leaves me with 8.92 is equal to 455 over vi cosine of theta. Now it's just up to you. Get vi by itself. So the math of it can be done a couple of ways. But we're looking for an end goal of vi is equal to 59.024 meters per second. Okay. So this one's a little bit tricky. I understand that. We're we're doing some heavy substitution with these. Okay. But when it's all said and done, it just ends up being, can you remember your premods or whatever it's called? Premods, I think it is. Power, exponent, whatever. That kind of stuff. Just gotta remember those rules. We're good to go. You'll get a question like this on the homework for this next week. So you'll get some practice with this some more. That's all I got. If I can hit the pause button. Oh, this is going to be awkward now. My mouse will not move. Oh, no.